Hi there, so in this video we're going to look at scattergraphs. Scattergraphs are a statistical diagram where the results are scattered around in a series of dots or crosses. Let's have a look. So you should have already met scattergraphs at National 4 where you've been asked to draw them and a line of best fit. At National 5 we are asked to find the equation of that line of best fit, but just to remind you of basic scattergraphs, here we go. Okay, so here are our three different styles of scattergraphs you can come across, and they have what's called correlation. Now think of correlation as being a bit like connection. So we use these scattergraphs to plot two different things together and see what happens. So in this first one, this is called positive correlation, and your line of best fit would go like this in a kind of straight line through the centre of all these crosses. Now if you were to draw a straight line like that, you would say that had a positive gradient. As you go left to right, it increases. So positive gradient, positive correlation. That's the way I remember it. Now, an example of this could be, along the bottom could be the time you're driving, and this could be the distance up the top. So maybe the longer you run, the further your distance. It could be like that. The second one, if we were to draw a line of best fit, it would be coming down the way from left to right. And in terms of the equation of a straight line, that would be a negative gradient. So negative correlation for this one. Now an example of that could be, think of the time it would take to do a job. Along the bottom could be the number of people. So the more people you have helping you out, the less time it would take you to do the job. So something like that. So that would be negative correlation. And then something like this, where the crosses are all over the place, there is absolutely no line of best fit, there is no connection, is called no correlation. And an example of that could be something like your age against your house number. I mean, why would you even want to know that? So there's no connection there, so we wouldn't bother putting that into a scattergraph. So a question has come up before in an exam asking what type of correlation this has, worth a mark, and that's been based on your line of best fit. Okay, so we want the equation of this line in terms of D and W, and there's a little T missing in there, apologies for that. Notice your X and Y axis are no longer X and Y, so they're D and W, but we don't deal with that till the very last step, so we'll treat as normal the equation of line. So we're going to get our gradient. Our gradient will be subtract the y's, 240 take away 210, all over 90 take away 70, which gives us 30 over 20, which simplifies down to 3 over 2. So our gradient is 3 over 2. My C value, I don't know my C value. So my tip is when you don't know C, we're going to use the equation y minus b equals mx minus a. I'd love to just point out though that some of you might prefer to use y equals mx plus c. In that case you would pick a coordinate, perhaps this one, and label it as x and y, sub in x and y to find c. But I like to use y minus b one now. So I'm going to use, instead I'm going to use x and y as a and b. So this is a, this is b. So I have y minus 210 equals 3 over 2 bracket x minus 70. I'm going to multiply the whole left hand side by 2 to get rid of that denominator. So I've got 2y minus 420 equals, that's dealt with the 2 on the bottom. So that's going to become 3 times the bracket, so 3x minus 210. 2y, the minus 420 I'm going to move over. So we've got 3x minus 210 plus 420. Again, some of you might skip that wee line. Leaving us with 3x plus 210. Last step is to divide everything by 2, giving us 3 over 2x plus 105. So that is what we think is the equation of the line. However, the y-axis has been changed to a d, so it's d equals 3 over 2. The x-axis has been changed to a w plus 105. And everything kind of sits there. It is a positive sloping gradient with a positive y-intercept. Okay, to sketch a scattergraph, your stuff will appear in a table perhaps like this. The x-axis is whatever's along the top, so along the bottom will be our hours. and up the side will be the thing along the bottom of the table, so that will be your percentages. And obviously your axis will change from X and Y to maybe P and H. What we do is we take each coordinate at a turn and we're going to plot it like coordinates. So along the bottom, hours are going to appear like this, 0 to 6. And up the side, I'm going to go from 40 all the way up to 80, taking every box is worth 2. To show they've cut a bit out in a scattergraph, they put a wee zigzag line there. That's because we don't need to show all the boxes from 0 to 40. It avoids having all your data away up the top of the scattergraph. Now you take each coordinate, each number at a time and plot it like a coordinate. So along 0 up 40, I'm going to do it in a slightly different colour pen. So along 0 up 40, 145, 155, and so on. So when you're done, your scattergraph will look a bit like that. Now is the time we're going to do the line of best fit. My number one tip is when you draw the line of best fit, you make sure it has a clear y-intercept, because that will make life so much easier for you when it comes to finding the equation of the line. So my line of best fit is going to be, I think I'm going to go roughly through 0.45 here and somewhere up through the middle of all my dots. That looks good. We've got a kind of even balance either side. Now to do the actual equation of the line, we need to now choose 2 clear coordinates somewhere along that line. Now it won't necessarily be a dot. You'll notice my actual line doesn't go through any dots, but it will, there will be some marks. So I'm going to use this as my first coordinate, my 0.45. And if I could just trace along the red line, there is a coordinate I could use there. There's another one. There's another one. I could choose any of those 4 coordinates. I'm probably going to take the one with the 3, this one here, to avoid having decimals. So I'll take the 365. And what we're going to do now is we're going to find the equation of this line. Okay, so our gradient of a straight line would be subtracting the y, so it would be 65 minus 45 over 3 minus 0, which gives us 20 over 3. Our c value comes from this coordinate here. Our c value is 45. That was what we made our y-intercept be. So our equation would be y equals 20 over 3x plus 45. But obviously our x and y numbers have changed. So it's p for percentage equals 20 over 3 times the number of hours plus 45. And that would be the equation of that line of best fit. What we would then normally do is they would ask you to use this to predict someone's score given for perhaps they studied for a given amount of hours. Okay, but we'll look at that in the next example. Here's one where the equation of the line of best fit has already been drawn, and you can see from it straight away, oh wait a minute, there is no clear c value, right? So because there's no clear c value, in fact I think my c value is probably going to be negative here. There's actually no need for that little zigzag on this one at all. So that shouldn't technically be there. There's no c value. My c value is probably going to be negative. So I'm going to use the y minus b line here. Again, your x's and y's have been changed to different letters, but you don't actually use that until the end. So find the equation of the line of best fit in terms of A and W, and then we're going to use this equation to estimate the weight of a 6-year-old. There's not too much information around this one. We just have age against weight. Whatever this is we're looking at, the older it gets, the heavier it gets. And that kind of makes sense in real life. So what I'm looking for are some nice clear coordinates on this diagram. So you go anywhere along your straight line. Here is the first coordinate I think I would possibly use here, the one I'm circling. As I go further along this line, I think there is another one. There is another one there. In fact, there's another one there. And I missed one way back at the beginning. So all these points I have circled would be the points I use. And notice only one of them is actually an X on the scattergraph, okay? So when you're choosing your coordinates, it's not clear dots. If there are clear X's on your line, brilliant. But if there's not, remember you're looking for nice exact coordinates using your grid against your line of best fit. So I would probably just go with this low down one. I'm going to choose that first coordinate here, which is a long one up 5. You can then choose whichever other one you want to do. I'm going to go use this one up here of 4 and 80. So let's use 4 and 80. So let's just check the numbers, 1, 5 and 480. Let's go get our gradient. So m equals 80 take away 5 all over 4 take away 1, which gives us 75 over 3. Now 75 divides exactly by 3 and gives us 25. So my gradient is 25. We're then going to use one of these coordinates and now label it as A and B. I'm going to go back to this first one, the 1 and the 5, because they're small numbers, and I'm going to use that. Into the equation of a line, we're going to use the y minus b equals m bracket x minus a, because you know that's my preference when you don't have your y-intercept. Plug in your coordinate y minus 5 equals 25 for your gradient and x minus 1. There's no fraction to worry about this one, so it's not too difficult. Y minus 5 equals, expand your bracket by 25, so 25x minus 25. You're going to move your negative 5 over, making it positive 5. Negative 25 plus 5, and again, some of you will skip that line. So you end up with y equals 25x minus 20. Now remember, we didn't have x and y axes. It was changed to different letters because we are correcting a formula. So your y-axis has a W beside it for weight, and your x-axis has an A against it for age, minus 20. So here is our formula for this line of best fit. And we're then going to use that formula to work out the part B. So part B in this question wants us to use our age of 6. So A is going to be replaced with the number 6. So our formula would turn to weight equals 25 times 6, take away 20. 25 times 6 we should all know is 150. Take away 20, which is 130 kilograms. So the weight of, I don't know what we're talking about, whether it's a child, an animal, or something else here, the weight for part B would be 130 kilograms. Okay, now that is a very typical national fact type question. Okay, and I have one more scenario for you. So in this one here, we used the equation or our formula, and we replaced the letter on the right hand side